right, is that the guy who came up with Python is European, and I don't know, maybe he went to Amsterdam that weekend when he came up with this, and or something, right? Okay, so another demonstration of this would be, what would happen if I tried to change one letter of the string? So for example, if I said this, right, I would be trying to change that H to a J, right? Let's run it and see what happens. The string object does not support item assignment. Okay, so I can't access, I can ask, what is the 0th character in the string? And that's a capital H. But I can't say, make the 0th character now be a J. Okay, this bothers me immensely because in C, you can do precisely that. Okay, so you can do this in some languages, but not all, not others. Okay, so strings are an example, and we'll probably talk about this a whole lot more over the course of the semester, of an immutable data type. You think you're changing their value, but you're not really changing their value. Python is kind of keeping up with the details behind the scenes. Okay, now here's something even crazier. Integers are immutable. Here's a demonstration of that. All right, so I can't do line 3, so let me comment it out. Oops. Okay, so what happened to the integer? Its original value was 5. It looks like I changed its value to now be 6, but what happened? It now has a different ID number, so it's actually a different thing with the same name. So to some extent, you don't have to worry about this because it sure looks like I changed the string or the integer, but in fact, I really haven't under the hood, okay, which is monumentally irritating to me, but that's okay. There's probably a good reason for it, and because I'm much more comfortable with C rather than Python, I think in terms of C. But yeah, okay. So does that kind of make some sense? A little bit of an issue. So what would happen if I wanted to change the string to replace the H with a J? I'd actually have to kind of make a new one, right? I can't do character by character changes that way, okay, which is a little annoying, but sorry, I didn't make up this language. Okay, you can also do things, some of the operations. What about if I've got 2 strings and I want to smush them together? Okay, what's that? What's a technical name for smushing? Yeah, Jacob. Yes, concatenate is the technical word. Okay, and you use the plus symbol to do that. Okay, so if I have, for example, if I concatenate the strings, then I get that. So what's the problem in this case with concatenation? It doesn't add the space that we would need for an English, for this to make sense in English, but that's not what concatenation does. Concatenation just takes 2 existing strings and smushes them together. And if you don't do the sound effect when you do that, then it doesn't count. Okay? Yeah? No. Okay, so questions on that, and then want to kind of talk the last thing for today. You can also do, by the way, this. What do you think that's going to do? World, right? So the multiplication operator does repetition, and the plus operator does concatenation. That's kind of cool. You can do that. So yeah, if Bart, you can't do that because it doesn't make sense, right? You know. So Thomas's question is, what would happen if I did something like this? Yeah. Okay. So it's obviously got to be an integer that you do that with. Okay. So the last thing I want to kind of talk about is comparison, right? So how do I know, for example, that capital H and lowercase h are different things? I mean, yes, we recognize this because they look different, right? They have different symbols. But like, if they're different, they have to be encoded differently on the computer. So how is that done? Okay, so this begs the question, how is text encoded on a computer? It's encoded in ASCII or Unicode, okay? So, for example, what is the difference between the capital H and the lowercase h? Okay, I can use this function called ORD to tell me that capital H is 72, but lowercase h is somehow associated with the number 104. Okay, now 72, would anybody have guessed that number? No, right? Because where are these numbers coming from? They're coming from a system called ASCII. Okay? All right, so let's go and look up an ASCII table. And in fact, let's just look up ASCII in the first place and go to the bastion of all knowledge of Western civilization, Wikipedia. Okay? American Standard Code for Information Exchange. It originally was a 7-point system. It was extended very quickly to be an 8-point system. And let's look at the list of it because there's a table in here somewhere. Here we are. The first 32 of these characters are not printable. Okay, and some of these are really old school things. For example, character number 7 is the bell. If you print character number 7, even today on some terminals, it'll go ding. So why would it go ding? Yeah, you guys remember, how many of you have ever used a typewriter in your life? Okay, other than when you were a kid and you went over to your grandma's house and there's a typewriter and you just sat there and banged on the keys because it was fun. How many of you have actually typed a paper on a typewriter? Okay. Okay, why did you do such a thing? Because it's cool, right? Okay, and on a typewriter, right, what do you have to worry about, amongst other things? Yeah, and what happens when you get to the end of the line? It goes ding. And then you have to move the carriage back and then advance the paper by one line, okay, so that you can then start typing on the next line. And what would happen if you forget to advance the paper a little bit? You would type over it, okay? And so returning the carriage, which is the slidey bit, over to the left is different than advancing the paper. Yes? Okay? And in ASCII, there are different character codes for those exact things. Okay, so we have, let's see, where is it? Yeah, line feed, and which is character A, and carriage return, which is character 0D. Right? Those are two different things on a typewriter. And there's a bell also on a typewriter. Okay, so the first 32, and there's obviously more than that, the first 32 of these characters are used for, well, things that aren't actually printable symbols. Okay, and now, do we use typewriters anymore? No, but we still have this legacy of them in our in how we encode letters. And a teletype, what is that? A teletype machine. Yeah, it's essentially an automatic electronic typewriter, but it's still a typewriter. Okay, and so if you wanted to program one of these things, then you would need that. Okay, now let's look at the actual printable characters, which start down here with the space. And what was the number that we got for our capital and lowercase h's? 72. And there's 72, right, is the h. And what was the lowercase h? 104. Okay, so in this case, you see the numbers that are in these columns. Which column am I looking at here? The light blue one, that's in decimal, meaning base 10. What's the one on the left? Well, so what do we have here? We have the binary. This is called octal, which is base 8, and essentially nobody uses that anymore. But old mainframes back in the day did, like the PDP-8 and stuff. Decimal, and then hexadecimal. Okay, so the capital H and the lowercase h, we can tell them apart because the number that's sort of associated with them are different. Okay, now what's really nice here is how do I get from, what was it, 70, what was the capital H? 72? How do I get from 72 to 104? What's 104 minus 72? 32. And so they're all offset by each other by 32 for the letters, right? So lowercase a is 32 bigger than capital A, and so on. Okay, and that maybe is a little weird that the capitals come before the lowercase. That's just the standard. That was just, I mean, somebody had to make a decision, and that's just the way they picked it. Okay. All right, we will continue with strings on Thursday. See y'all later.